Here at the gate terminal, we receive LNG, store it in our tanks and then pass it through our terminal area where it is warmed up before entering the gas distribution network. To achieve that fairly simple process, we require the use of various pumps and compressors supported by a range of utilities, from firefighting systems to instrument air systems and nitrogen systems. In the last few months, we've basically come towards the end of the civil works construction and started the mechanical works, whereby we've erected lots of structural steel work, and on that we're starting to place various vessels, piping, high pressure pumps, and of course we also have the buildings where our electrical supply and instrumentation is housed. We have a greenfield site where it's been reclaimed and therefore we know the ground conditions. The sand itself does give us a problem because we do strive to achieve a very clean build process to avoid any dust and debris getting into valves and pipework and such like. But principally it's a fairly easy location to build. All of the different areas are essential to the overall scheme of things. Without the jetties we couldn't unload the ships, but essentially this is the heart of it, whereby everything comes together, and from here the process of receiving the liquid from the tanks and increasing the pressure, warming it up, the transition to its gaseous phase and then sending it out through the metering into the grid takes place. Again, without this, the rest of it would not work. At the moment we're stood high up on the recondenser structure overlooking parts of the terminal site. In the distance is the shipping channel whereby the LNG carriers would enter and berth alongside our two jetties. From there the LNG flows through our unloading line, which is essentially the white pipeline you see. It comes through the MOT oil storage facility and enters the terminal part of the site in the short distance in front of us. From there it continues to flow through the system, along the pipe track and up the vertical pipes to be installed, and it enters the tank through the top. From there the liquid is then stored until we need to pump it from there and send it out into the system. With the LNG in the storage tank, it does collect some heat and generate some boil-off gas. To deal with this, we have to recover it rather than to release it to atmosphere. To achieve that, the gas flows from the tanks down and through some of the compressors which are housed in this building in front of us. From there, the gas flows through the recondenser vessel, which is here in the structure behind us, whereby it gets reintroduced to a stream of liquid natural gas which flows through the vessel. From there, it enters the high pressure pump area. Here we are at one of the branch connections that will feed warm water from the warm water line running from the Eon power station up into the manifold on the ORV structure behind me, where the warm water will then just be cascaded across the open rack vaporiser and exit at the bottom of the structure and be fed into the seawater channel. When the LNG enters the vaporisers, it flows through some thin-walled tubes where it starts to receive heat from the warm water which is cascading over the vaporiser tubes themselves. At that time the liquid expands about 600 times into its gaseous form, so that when it exits the vaporiser it's at a temperature of about 0 degrees centigrade. At this location, at the metering area, it's the point whereby the gas leaves our terminal and enters the gas distribution network. Prior to doing so, we have to measure temperatures, densities, gas composition, and of course the volumes of gas which leave our terminal. Over the coming months we'll start to complete some of our construction work such that our systems can be individually tested, the electrical systems energised, instrumentation systems tested and safety systems put into operation before we receive our LNG carrier in the middle of 2011.